Okay, so this is the lesson titled Seed Dispersion, and again it's going to come back to DNA and how plants and animals, and specifically plants in this lesson, get their DNA from one place to another, and how the DNA actually affects how they get their DNA from one place to another. So the two standards that this lesson is going to cover are 8.3.2. Students will investigate and describe the relationship between reproduction and heredity. And 8.3.4, students will identify characteristics of organisms that help them survive. And so we've already done our DNA extraction lesson, and we've done our lessons on camouflage as an adaptation, and we've done our lesson on bird beaks as adaptations. And so this is our final sort of lesson about adaptations. And in this lesson we're also going to talk about mutations, and how mutations in changes in DNA are actually what give rise to new species, and actually is what gives rise to all the variety of species that we have on Earth. And we're going to specifically focus on how plants get their seeds from one place to another. So using wind, water, other animals. And the way this activity will work is we'll start off with a discussion. We'll be using the PowerPoint that I've got below this video, and talking about different seed types and why it's important for plants to get their seed from one place to another. Mainly so that they don't have to compete with their offspring. And after a discussion, then students are going to be trying to create the ultimate seed pod for wind dispersion. So they're going to be getting a lima bean, or a kidney bean would work, and a cotton ball. Okay, and that's going to be their starting materials. And they can use as much tape as they want. And they're going to be trying to design some sort of seed pod to drop in front of a fan, and we're going to see how far each person's seed pod goes. And obviously the person whose seed pod goes the farthest would be the dominant plant in our ecosystem, the dominant tree. They'd be able to spread into new locations faster, and their seeds would get farther away from other plants and trees and have a better chance of survival than their classmates. So after 5 minutes of building, we'll test it. And then after that, we're going to add a mutation. Right? And the mutation is going to be, each student is either going to get a piece of tinfoil, about 3-inch by 3-inch piece of tinfoil, or a Kleenex. And at this point in time, I'm going to talk to the kids about genetic mutations and what it means when DNA changes. Most of the time, those mutations are harmful. You know, over 99% of the time, a change in the DNA is a very bad thing. But occasionally, you get a mutation that actually benefits the species, gives it an added edge in the competition with the species around it. And that's how we get really interesting species being formed, and how we get really interesting seed pods in this case. And so each student, or if they're working groups, each group of students will have another 5 to 10 minutes to use their new mutated supplies, because they've had a mutation in their DNA, they have new materials to work with, to build a better seed pod. And then again, we'll test them, and we'll talk about whether those mutations were beneficial or whether they were harmful. Just really quickly, I thought it might be beneficial to show you sort of some examples of different seed pods students might choose to build, and then I'm going to actually drop a couple in front of the fan so you can see exactly how this works if you were going to do this activity in your room. And so again, you're going to be starting with some sort of dried bean and a cotton ball. And students can use it. I always say students can use as much tape as they want, because really it's not an advantage when you think about the added mass. And okay, so this is an example here of one type of seed pod, and you can see the bean is right here, and then I've got the cotton spread out all around, hoping to catch as much wind as possible. So that'd be an example of the type of seed pod students might build before there was a genetic mutation, so all they had was the cotton and the seed. Now, basically, after we test those, okay, then we are going to have a genetic mutation, and students will get to choose between a tissue or a piece of tinfoil. And obviously, in nature, plants and animals are not choosing the mutations they get, but in this case, I'm going to let students. And so one example might be like this tissue pod that I built, and I'm going to put the bean just right inside of the tissue pod. And my goal with this is that this will fly through the air, and when this hits, the bean will actually kind of explode
out and go farther than the seed pod itself, because we will measure where the bean itself goes. Alright, so let's drop these in front of the fan and see how they do. Obviously the size of the fan is going to make a big difference in how far these things go. It'd be helpful if you had a fan that was on a stand up a little bit higher in the air, so these can start from a little bit greater height off the ground. We know plants are obviously up off the ground, and so if you have a fan really close to the ground, it's not maybe as realistic or as good for the students, because their seeds are not going to go as far. It's not going to be as exciting. So I like to start the fan on high always, and kids are going to want to try to throw these things, but again, they just have to drop it. So try this one. Okay, that one went approximately 1 meter. You got a meter tape out on the floor here, and I'll try this tissue one here, and we'll see how it goes. Well, that one went about 1 meter too, and the seed did not come out. And so, that particular time it didn't work. Sometimes I've had it where it does work, and so that's another thing that we can talk to students about together, is that sometimes a lot of the plant's seeds don't get very far away from the plant. I mean, if it's not a windy day, and that's when the seeds fall off of the tree, then they aren't going to get as far as if there's 35-mile-an-hour gusts when the seeds fall off the tree. And so these seed pods are designed to get as far away from the tree as possible. Sometimes you don't get as lucky. So it might be good to let students try a few times. And always, as in all the activities, if you have the time, it's really important to let students work and rework these things as they think about how to engineer, a seed pod that's going to get their seed to go the farthest. So in closing, again, this lesson is really about getting students to think about not, just about seeds and seed pods, but also about how powerful, again, this molecule of DNA is, and how a very small change in this DNA can sometimes, very occasionally, over the span of, thousands of generations of species, sometimes a small change, a mutation, can actually benefit a species. And that benefit then, if it helps the species to survive, if it's a good adaptation, is going to be carried on within that species. And sometimes, if the species becomes diversified enough, different enough from the original species that the mutation occurred in, it becomes its own species. And that's how we get different species, and that's how we get all of the amazing camouflage, bird beaks, and seed pods that we've looked at over the last 3 lessons together. And so as the classroom teacher, it's really important to encourage students to think about how cool it is that small changes in DNA, just mutations, random mutations, can give rise to such amazing diversity of life on Earth. And so some ways to follow up this lesson would be to allow students to, to continue the engineering part of the lesson. It would be allow students to think of another additional material they might like to add as a mutation. You could even have a fun competition where you assign an over-the-weekend project for them to use any materials that they have around the house to try to build the ultimate wind-carried seed pod. Go to the gym, set up the big gym fans, and have a good time with your class, and drop them in front of them and see who can get their home-engineered seed pod to go the farthest. That's a way to continue the engineering part of this lesson. And of course, the way to continue the idea of change over time, species evolving over time, would be to research how species have changed over time. Find examples of ways that species have changed over a shorter period of time that's observable to humans. Right? Or just have students in general research an interesting plant or animal and come up with the adaptations that that plant or animal has, and how they work, how they help the species to survive, and maybe, why they have the adaptations they do. I mean, what's the point of them? And I think that will help cement in students' mind the idea that, animals really have changed over time to fit into their environments. And we'll talk in future lessons about how if environments change too quickly and animals can't adapt fast enough, that's when we get extinction. So I think that's it for this lesson, and we'll see you next time.